All right, so co-functions of complementary angles. So this is really just recognizing that sine of theta and cosine of theta are the exact same graph, just horizontal translations of each other. So we talked about this a little when we were graphing sine and cosine. If I were to shift my graph sine over I have units, I would get cosine. All right, so that's what this right here is saying. It's the identity that sine of theta, sine of pi halves minus theta, is equivalent to cosine of theta. Cosine of theta, a cosine of pi halves minus theta is equal to sine of theta. Tangent of pi halves minus theta is cotangent of theta. A secant of pi halves minus theta is secant. Secant of pi halves minus theta is cosecant. And cotangent of pi halves minus theta equals tangent. So pause the video, make sure you have these also on your purple sheet. We are now going to look at using these identities to help us simplify as much as possible as well. So cosine of pi halves minus theta, using our identities directly above here, is equal to sine of theta. Which, when we have sine of theta over cosine theta, reduces nicely to just be tangent of theta. Tangent squared of 90 minus theta. Well, recognizing 90 degrees is equal to pi halves. So all of these could be substituted with 90 degrees. All right, so when we go, I have tangent of 90 minus theta I can identify, but I don't have a tangent squared. So it's important to recognize that tangent of 90 minus theta times tangent of 90 minus theta. That's what it means to square something. You multiply it by itself, right? So I do have what tangent of 90 minus theta is, and that is cotangent. Which, when I multiply cotangent, I get cotangent squared of theta plus 1. I have a squared trig, so go back and look at your Pythagorean identities. Cotangent squared of theta plus 1 is cosecant squared of theta. So you should be noticing this purple sheet is going to be extremely important to you. Do not lose it. All right, secant of pi halves minus theta times sine of theta. Well, secant of pi halves minus theta, looking at your identity sheet, is cosecant of theta times sine of theta. Those are reciprocals of each other. So this is really 1 over sine of theta times sine of theta, which gives you 1. So that's just simplifying. When you're actually solving what we refer to as an identity, there are some rules. You work only on one side. So an identity is going to be a statement, this equals this. You will choose one side or the other and work entirely on this side so that you finally show it equals what you originally stated. I do ask when you're doing these that you work down the page as much as possible because it's just so much easier to read and follow as we go. So the easiest way to kind of visualize this and see this is to just do some examples together. So establish the identity. I will say when you're choosing the side you want to use, it's actually easier to choose the more complicated side because it's easier to reduce than it is to expand, right? So when I look here, I need to show that sine of theta plus cosine of theta squared plus sine of theta minus cosine theta squared is 2. I'm going to work exclusively on the left side, and I'm going to show that it equals 2. Now, you need to actually square these binomials out. So remember, so this is going to be 2 sine of theta squared. The last is cosine plus squaring sine theta squared, so sine theta, minus 2 sine of theta cosine theta minus cosine squared of theta. And that should reduce to 2. Oops, I made a mistake. So looking here, well, what happens? I have a 2 sine of theta cosine theta and a minus 2 sine of theta cosine. Those can square up. And what do I really have? I have sine squared of theta plus sine squared of theta plus sine squared of theta plus cosine squared of theta equals 2. Well, this is a Pythagorean identity equal to 1. This is the Pythagorean identity equal to 1. So what do you have? 1 plus 1 equals 2. So what I mean by working down one side is I'm working entirely on the left side of my equal sign, and I'm stopping once I show that it equals the right side. All right, so cosine squared of theta times 1 plus tangent squared of theta. I need to show that that equals 1. All right, so once again, when I see a function squared and a 1, I know I want to look at my Pythagorean identities. So if you look at your identity sheet, 1 plus tangent squared of theta, well, that is secant squared of theta. So now I have cosine squared of theta times secant squared of theta, which secant is 1 over cosine. So secant squared is 1 over cosine squared of theta. Those cancel and you come down to 1 equals 1. For tangent plus cotangent equals secant of theta times cosine of theta, I will say here it's easier to go from addition to multiplication than it is to go from multiplication in terms of addition. So here you want to work with the addition side. All right, so tangent of theta, sine of x over cosine of x, plus cotangent of x, cosine of x over sine of x. Now I need to find my common denominator. My common denominator being cosine of x times sine of x. To get that, I had to multiply this by cosine, or by sine rather, so sine squared of x, to go from sine of x to sine of x to cosine of x. So this is going to be cosine squared of x. My numerator, sine squared, is my Pythagorean identity. So I have 1 over cosine of x times sine of x, which I can break apart because it's in terms of multiplication. So that's 1 over cosine of x times 1 over sine of x. And I'm only allowed to do this because it's just multiplication in my denominator. 1 over cosine is secant of x. 1 over sine is cosecant of x, which is what I was trying to prove. So identities, when we're doing these together, probably seem like, okay, this is obvious. They can be really tricky. The thing is, you have to just try. You can't just get it always on the first try. So it's going to take a little practice here in getting used to some of the tricks and some of the substitutions. And you may substitute something for tangent. You may have used like 1 over cotangent. And you may get going and realize it doesn't work, and that's fine. But you just need to try something else then, right? So I'm going to stop this video, and next we're going to move on to even and odd functions.